now we'll see in under module 1 source transformation. Source transformations is whenever I have an voltage source, I want to convert that voltage source to a current source, or from a current source to a voltage source, we go for source transformations there. So we know that our ideal voltage source is nothing but a voltage source in series with a resistance R there. So when the voltage source is going to be in series with a resistance R, and in some of the applications, and I want to simplify my circuit, I have to reduce that voltage, I have to convert that voltage source to a current source there. So here in this case, I am going to consider a practical voltage source there, where this voltage source is going to be in series with a resistance Rs. So I want to convert this voltage source to your current source there. So here V is equivalent to I into R. So that means that we know that your V is equivalent to I into R. So your I is equivalent to V by R. So what is the voltage I have here? It is your ES. So that is nothing but the voltage is going to be ES, and the total resistance that I am going to have in the circuit is going to be your RS. That is, this voltage source, if I want to convert, the series resistance is going to be Rs. So here I am going to convert this voltage source into a current source, where current source is equivalent to E by Rs. And always we know that your current source should be in parallel with your resistance Rs there. So here we are going to have a load resistance to be connected there. Now if I want to find out my load current IL, so your IL is equivalent to I want to find out my VL. So VL is nothing but, so VL is equivalent to your IL into RL, the load current into your load resistance RL. We know that your IL is nothing but your total voltage. That is going to be, if I am going to apply my KVL, a KVL is equivalent to, so minus to plus, so minus to plus is going to be a plus ES. So current is flowing like this. When current is flowing like this, when current enters, this is going to be plus sign, this is going to be minus sign. Similarly, when current enters like this is your plus sign, and this is going to be a minus sign. So the current that is going to flow through this circuit is going to be your IL. So ES plus to minus is going to be your minus IL into RS. So RS, again plus to minus IL into RL is equal to 0. Now if I find out what is IL is nothing but ES divided by RS plus RL. So I can substitute, your VL is nothing but your ES divided by RS plus RL into RL there. So your load current IL is nothing but, from this equation we can see that it is ES divided by RL plus RS. So here we say that your load current is your, if I am going to have it as a current source, I can write my current divider rule. Current divider rule is nothing but your total current. Total current is nothing but IS. See here your circuit is going to be, this is going to be your IS, your total current, in parallel with your source resistance, that is going to be RS, and this is going to be your load resistance RL. Now I want to, the current that is going to flow through this load resistance is going to be IL. So your load current is equivalent to your total current. Total current for this circuit is nothing but IS into, what is the opposite resistance to this load resistance is RS divided by your total resistance. Total resistance is nothing but RS plus RL. So you can write your load current flowing through the circuit is nothing but IS into RS divided by RS plus RL. So here we can say that you can equate these two equations there. The load current in the previous case was when voltage source is ES divided by RS plus RL, and in this case it is going to be IS into RS divided by RS plus RL there. So here I can have these two parameters to cancel. If it's cancelled, it is going to be ES is equivalent to IS into RS, or IS is equivalent to ES by RS. So to convert an voltage source into a current source, what is that? IS is nothing but ES by RS. So here source shifting. So source shifting is nothing but I am going to shift the voltage source there. So how the voltage source is going to be shifted is, so I am going to have a single voltage source that is going to be connected in series to your resistance and your inductance there. So I can redraw this circuit. The single voltage source is connected to both your resistance and inductance. So I can have it as your resistance. This voltage source can be connected to resistance as well as to your inductance there. So this voltage source is connected to your resistance as well as to your inductance there. So now this source is shifted to both the elements that is going to be present in your circuit. Now next is shifting of current source. So shifting of current sources, I have two resistances, and these two resistance are going to be connected to a single current source I1. That means that my current is starting from this point and it is going to flow through like this and it is going to end at this point there. So how I can connect it is from C to B. So I can have my resistance R1, this resistance R1, this resistance to be R2. The current, I can have this current to be flowing from here to here and it is going to end here. Again from here to here, the same current is going to flow and this is going to end here. That means that I can have my current divider rule. That is, your current flows from C to B and B to A. The same I1 current flows like this. So my current source is going to get shifted there. So here, suppose if it is going to be like this, my current starts at this point, it ends at this point. So what I can do is I can draw. My current starts from this point, ends here. Current starts from this point, it ends here. Current starts from this point and this ends here. So here, this is the starting point. So starting point means current starts from here, it ends here. Starts from here, it goes like this. Starts from here, it goes like this there. So this ends here. Starts from here, ends here. So I can redraw this current source there. This is how your current source is getting shifted to various other resistors that is present in the circuit there. So now we'll see an example. You find V0 using your source transformation circuit. So to find your V0, we see that I have an voltage source to be present in my circuit, a current source to be present there. I want to find out what is going to be the voltage that is going to be present across your 100 ohm resistance there. So to find out the current across this voltage across this 100 ohm resistance, what I can do is, this is your voltage source, this is your current source. So now I have to decide which source I have to reduce it. So if I reduce this, it is well because these two resistance, this is your source is present. So what I'll do is, I'll consider this source, your voltage source and current source, I'll convert it to your current source there. If I convert it, your I is equivalent to V by R. V by R is nothing but your 250 divided by 25. So 250 divided by 25 is nothing but 10 amps. So current direction is, here down is minus, this is plus. That means I'll replace it as like this. Wherever is the plus sign, this head of the arrow should come. So this is your 10 amps in series, in parallel with your resistance 25 ohms. Now I have two current sources to be present. But in this case, your current source, this is 10 amps is going in the upward direction and 8 amps is in the downward direction. So in opposite directions means I have to subtract it. So if I subtract it, 10 amps minus 8 amps is going to be 2 amps. In this case, 10 amps is greater, so the arrow mark will be on the top. So 2 amps. Now we are going to have a resistance 25, a 100 and 20 ohms to be in parallel. So first I will find out what is 25 parallel 20. So 25 parallel 20 is going to be your 500 by 45. Again, this 500 by 45 in parallel with your 100 ohms is going to be totally 10 ohms. So I will redraw the circuit. It is going to be 2 ohms. This resistance is going to be, your equivalent resistance is going to be 10 ohms. Now we are supposed to find out what is going to be the voltage across this 10 ohms. So here this is your 2 amps current that is going to flow. So this 2 amps will be flowing like this, and here it is going to be 2 amps. So when this 2 amps flows, your V0 is equivalent to 2 into 10. So 2, so you are going to have 2 into, current is 2 and this is going to be 10. So the total voltage is going to be 20 volts there. So here the total output voltage across the 100 ohm resistance is going to be 20 volts. So next we are going to consider a circuit where we want to find out the voltage measured by the voltmeter there. So in this case, if I am going to see, I am going to have, I want to find out what is going to be the voltage across this voltmeter there. To find out, first what I am going to do is, I am going to convert this voltage source to your current source. So when I'm going to find this voltage source to your current source, your I is equivalent to V by R. So V is nothing but 4, R is nothing but 6. That means it is going to be 2 by 3. So 2 by 3 it is going to be there. But the direction if I see it is going to be plus. So when I am going to draw it, my current source will be like this. So your head is nothing but positive. So positive is going to be 2 by 3 amps in parallel with your resistance 6 ohms. Again I am going to have your 12 ohms to be present. Now I can see that you are going to have your 6 ohms and 12 ohms are going to be in parallel. So when 6 and 12 are going to be in parallel, I can reduce that 6 and 12 to be in parallel, that is nothing but 4 ohms. So your equivalent resistance value is going to be 6 into 12 divided by 6 plus 12. That means that 72 divided by 18. So 72 divided by 18 is nothing but 4 ohms. So here it is going to be replaced as 4 ohms, 2 by 3 amps. And we are going to have your 8 volts, 12 ohms to be present there. So now what I can do is I can convert this to your voltage source. Convert it to your voltage source. When I convert it, V is equal to I into R. I is 2 by 3. So 2 by 3 into 4. So 2 by 3 into 4 is nothing but 8 by 3 volts there. So I can have this 8 by 3 volts. So this is the downward direction is downward direction here. So that means that this should be plus and this should be minus. So here I am going to have plus, this is minus your voltage source in series with your resistance 4 ohms. And now I have your 8 volts 12 ohms. Now these two, what I can do is, this is plus to minus. So plus to minus means always it is going to be minus 8 by 3 whole. Plus 2 minus means minus. Minus 8 by 3. Here is going to be plus 2 minus minus 8. So if I take the LCM, it is going to be 3 8s 24. 24 is minus 32 by 3. So your voltage is going to be 32 by 3 volts. And your resistance is going to be here in series. So here in this case, this is your 4 ohms to be present there. So in the next circuit, if we see, you are going to have a 32 by 3 in series with your 4 ohms. Now I have my 12 ohm resistor. So what I will do, I will convert this voltage source to your current source. So when I convert this voltage source to your current source, it becomes 8 by 3 amps in parallel with your 4 ohms. So this 4 and 2, here in this case it is going to be parallel. So when it is going to be in parallel, I can simplify it. So 4 into 12 divided by 16. So here in this case, 3 ohms. So 3 ohms is going to be here your 8 by 3 amps and you are going to have your 2 amps there. So now if I am going to apply your KCL is nothing but your incoming current is equivalent to outgoing current. So I want to find out what is going to be the total voltage drop. So here this is your current, incoming current. If I am going to consider this to be a node, your KCL is nothing but the sum of the outgoing currents. Incoming current to this node is going to be 2 amps. So incoming current is 2 amps. Outgoing current is from this node, the current is outgoing. So this is nothing but 8 by 3 plus your I value. So I plus 8 by 3 is equal to 2. So I is equal to 8 by 2 minus 8 by 3, that is nothing but minus 2 by 3 amps. So minus 2 by 3 amps means the drop across it will be 3 into minus 2 by 3, that is nothing but minus 2 volts. So the voltage across your voltmeter is going to be minus 2 volts there. So a source transformation is, we are going to use a source transformation technique to reduce the circuit there. So here in this case, if I see, I have 2 voltage sources to be in parallel. So if I have 2 voltage sources to be in parallel, what I can do is, I can neglect this voltage source. So this I need not consider itself. I can start considering from this part of the circuit. So my circuit is going to have the voltages 20 volts, 10 ohms, 10 amps and 10 ohms. So now to simplify this circuit, what I can do is this 20 volts, 10 ohms, I can reduce it into a current source. So if I reduce it into a current source, a plus sign is down here. So it is 20 by 10. So 20 by 10 is going to be your 2 amps. So 2 amps in parallel with the resistance 10 ohms. So in this case, current direction is both same. 2 plus 10 is going to be 12 amps. These two resistance are in parallel. So 10 into 10 divided by 20, that is nothing but 5. So if I convert it into a voltage source, it is going to be your, so this is plus, this is minus. So a battery voltage should be here plus, this is your minus. So 12 into 5, 60 in series with your 5 ohm resistor there. So this is how we are going to simplify the equivalent circuit there. So here we are going to find out your V2 in the following circuit. So when I am going to find out your V2 in the following circuit, you are going to have your voltage dependent sources there. So here your 72 ohms is, I am going to convert it to your current source. So when I am going to current it into your current source, 72 by 4, that is 18 amps in parallel with your 4 ohm resistor, 6 ohm. This time again I am going to convert it to your current source, 3V2 divided by 12 ohms there. So in this case your plus sign is facing, your plus is facing downwards. So your current direction also should be downwards there. So this is 0.25. Now you have to, all these three resistors are in parallel. 4 is parallel, 6 parallel, 12 is nothing but 2 ohms. So when it is going to be 2 ohms, your current directions are going to be your V2. Your V2 is nothing but 36 divided by your 1.5 volts. So solving for your V2 is going to be your 36 volts divided by your 1.5. That is nothing but 24. So here in this case V2. How to find out your V2? Your current, one current is in the upward direction, the other current is in the downward direction. So V is equivalent to I into R. So V is equivalent to I into R. I is nothing but your current is nothing but your 18 minus your 0.25 V2 into your resistance value is going to be 2 ohms. So if I multiply it, in this case your total voltage is going to be your V2 we want to find out. So if I am going to find out my V2 voltage, that is nothing but, here in this case simplify this equation. It is V2 is 36 by 1.5, it is 24 volts. So V2 is equivalent to V2 plus 0.25, that is 0.5 V2 is equivalent to 36. So it is going to be 1.5. So V2 is equivalent to 36 by 1.5 divided by 24, that is 24 volts. So we are going to reduce your circuit into a single voltage source in series with your resistance between the terminals A, B. So if I want to reduce it, what I can do is I can convert. Anyway, your voltage source, here I am going to have a voltage source cannot be in parallel with your resistance. So I should neglect this resistance first. Redraw the circuit. If I redraw it, it is going to be 10 volts 2 ohms in parallel with 5 ohms and 10 amps there. So here down I am going to have a 6 ohms. Always a current source in series with your resistance means that resistance can be neglected there. So 6 amps, here 4 ohms there. So now convert the top to your current source. So 5 amps and 2 ohms there in parallel. So these two current sources are in same direction. So it is 10 plus 5, 15 in parallel with 10 by 7. So convert it into an equivalent voltage source. It is nothing but 15 into 10 by 7 is 150 by 7. Then in series with your resistance 10 by 7. Here it is going to be 24 by 24 volts and 4. So now minus 2 plus is going to be a plus 24 plus 150.7 is nothing but 45.43. And the resistance is going to be 5.43 ohms there. So here we are going to reduce the circuit given in the figure below into a single equivalent circuit there. So if I want to convert it into a single equivalent circuit, convert these voltage sources to your current sources, then add these two current sources, I'll be getting this, convert this current source to your voltage source. If I get this, then in this case I can add this and I can have it as 14 volts and this series resistance is going to be 3 ohms. If I want to equivalent to convert source, that is 14 by 3 is going to be 4.667 in parallel with your 3 ohm resistor there. Thank you.